Hello, welcome back to Cracking the Cryptic, and happy Halloween to those that celebrate it or get through it. And this is the real one. I know a couple of days ago I thought it was coming yesterday, but that's just Mark's Halloween. I also know that if you're in New Zealand or Australia, it's been and gone already by the time this comes out, and for many other places too. So bear with us. I have waited till it's got dark tonight to film this. We will get to the puzzle in a moment. Now, Halloween means the end of the month, and that means tomorrow is a new month. And for us, that means, it's a new month for us starting tomorrow. Again, well, you're already there if you're in Australia or New Zealand, but you do not have our Patreon reward for the month, which will be coming up at 4 p.m. our time tomorrow. I think Simon might also put up his solution to Zeta Math's Two Truths and a Lie. So there's both the Paint by Numbers Institute Japanese Sums puzzle pack coming and that Zeta Math solution video. So loads going on Patreon, and at some point soon we are going to be putting up the remaining videos, which have all come in now to the padlocked lockout lines pack. So thank you so much to the creators of those puzzles who have managed to assemble all the videos to the individual puzzles. We'll be putting the remaining ones up at some point as well. So tons going on Patreon. Do join if you haven't already. Always tons going on Discord. Have a look in there at some point. Very welcoming crowd as always. And we welcome you to try our apps and the Sudoku Pad. So lots going on the channel as always. Oh, and we'll be streaming tomorrow. Even better. We will be streaming a bit more of the return of the Obra Dinn at 10 p.m. our time now. The clocks have changed. So if you're, the clocks have changed in the UK, they have gone back an hour. So that'll be an hour later if wherever you are, you haven't exactly copied the timing of our clock change for daylight savings, etc. So anyway. It'll be 11 p.m. It'll be 10 p.m. our time, which is an hour before when this video just came out. So you can time it that way. Right. And I will be releasing another video while that stream is on as well. So loads going on the channel as always. We keep up the pace of 2 a day. But as I said, this is Halloween and we have a puzzle from James Kopp called The Spectre. Now, if you look very closely at this puzzle, apparently there is an image of a ghost. You may see that ghost if you look closely. Look hard. Can you see it? There it is. I hope you can see it now. Anyway, I can. Right, now, normal Sudoku rules apply. A clue outside the grid shows the sum of the digits along the indicated diagonal. So these digits add up to 11. They could contain repeats if that was allowed by normal Sudoku rules, which it isn't in that case. Grey circles, the eyes of the ghost, are odd numbers. The grey, actually it looks a bit like Simon with glasses on when you do that. The grey line is a palindrome, reading the same from both directions. So that cell must be the same as that must be the same as that, and so on, all along the line. Now I hope this isn't as tough as the last little killer I did from Directionary. That really bamboozled me for a while, but we shall see. Do give it a try on the link under the video. And I'm going to start now. Happy Halloween, and let's get cracking. Right. Let's start with a 7 clue down here. That must be the numbers 1, 2, and 4. And right next to it, an 8 clue. And in this box now, that's got to be 3 and 5 because we've used up the 1, 2, and 4 in the box. That's all well and good. Right, this 7 clue is quite helpful. Now, the minimum that this could be is 5. If you had a 1, 2 there and 1's either end, this could be 5. Right, but let's see what cells those are on the palindrome. 1, 2, 3, 4, 5. They start at number 6. 1, 2, 3, 4, 5. They're those 3 cells. Now that's helpful. They have to be different. So the minimum they can be now is 1, 2, and 3. And if that's 1, 2, and 3, that is our first digit and is a 1. And we can fill in 1, 2, 3. Probably we'll just remember that they're a triple. Don't know what to do about that. Right. Oh, hang on. What's the minimum way of doing this 11? Oh no, I was thinking it's got to be 2, 4, 5, but that's not true because this could be 2, 3, and then it could be 1, 4, 6. Yeah. So either 1 or 2 is on that line. Yeah, I'm just not sure. Might be missing a trick here. There's definitely a 4, I think. 4 in font type today. A 4 in one of those cells, I think. I'm fairly confident that's right. Right, so the center of the palindrome is between those two cells. Oh, so they're the same on this 34 diagonal. So they can't be as little as a 7, because that would leave 20 for these other two cells. So they must be at least 8. I'm going to just mark them as the same. Actually, now I'm being inconsistent with my markings. I'm going to take out these purples. Just try and remember that that is a 1, 2, 3 set. Actually, this can't be a 1. Ah, that's there. Right. Now there is a 1 in these two. And now this can't be 1, 4, 6, and it is 2, 4, 5, which was my instinct originally. So we get a 1, 3 pair there now. 4 plus 1 is 5, plus a 2 there is 7. And that's a 2. That's a 2. Palindrome, and we've got the 1, 3 pair mirrored in those two places. Now, on this 34 diagonal, let's start here. I'm going to come back to the unfilled cells in in boxes 3 and 9 in a minute. Now, on this little killer clue, if those are 2 8s, then we need 18 more in those, which is going to be 2 9s. So that's one way of filling this. Otherwise, they're 2 9s, and these have to add up to 16. Now, that always feels like it must be 7 and 9, but of course it could be a pair of 8s. But these are still quite high. That is the match of that on the palindrome, so it's 7, 8, or 9. Yes, and what I was going to do here is notice that all of these cells are the remaining digits that aren't 1, 2, 3, 4, and 5. They're 6, 7, 8, and 9. And look, that's a quadruple in the top row, so that's great. Now, this can't be a 2. So these are from 1, 3, 4, and 5. Oh, look, they've got a 1, 3 pair looking at that one. So now we've got a 4, 5 pair in the top row, and therefore a 1, 3 pair. Wow, this is quite a nice start. That can't be a 1. Let's just point that out because of this. Now, I haven't used this 22 clue. These are somewhere between 13 and 17. These two add up to somewhere between 5 and 9, which is a bit too flexible to be much use. 32. There's only 2 less than 34, but that is a lot more degrees of freedom, which is annoying. Starting to wonder about these 3 cells, which must be those 3. Don't see how to use those. What about this 39? Okay, these 2 cells are the same as these 2 in reverse order. That's that, that's that. So they're from 6, 7, 8, and 9 now as well. Right, what does that mean for the 39 diagonal? 1's interesting, actually. Now we've got to make up 38 from those. So there must be a repeat digit, because 5, 6, 7, 8, 9 only adds up to 35. So we're looking at pretty high numbers. The most those can be is 17, 9 and 8. Then these have to add up to 21. So this could only go down as low as 4. The most these can be is 24, plus 1 is 25. The least these can be is 14, so that could be 5, 9 or 6, 8. But 5's the lowest there, so we're not quite forming a quadruple. If we could rule out 5 from those, we'd have at least 1, but we can't, so a bit of a pipe dream there. Now this is also on the 32 diagonal. Oh, do we know? Yes, this is on the diagonal. Okay, sorry, I should notice that immediately. So that becomes 5, 6, 7, 8, or 9. That one is there, which isn't very helpful. Actually, okay, maybe this diagonal's a bit better than I realized. Yeah, okay. What is the minimum value in a cell? I mean, there are more degrees of freedom than on this one, but there aren't that many actually. So if we had 9 and 8 there, 17, and 9 here, 26, 6 is the minimum on one of the outside cells. That's got to be the same here. So 4 and 5, I think, can disappear. 17 plus 9 would be 26. 6 is the least that can be here. So now these have to add up to a minimum of 21. Which would make those 17. Now, this can still be a 5, and this can too, because the 3 degrees of freedom, if they came out of a 9-8 pair, could leave a 9-5 pair behind. So those can both still be 5, I think. This is on the palindrome though, but 5's the lowest it can be. That's here. Now we've got 4 of these cells that have to be at least 5. Getting closer. I've been ignoring this 48 diagonal, but actually, wasn't there a 48 diagonal in Directionary's puzzle in exactly the same position that tidied up the whole puzzle at the end? I think we might get the same here. That's a weird coincidence, because this puzzle was sent in long before we showed that. Weird. Anyway, I don't think we can use that 48 diagonal now, but just notice that. Right. What are we going to do next? This 22 hasn't changed. Okay, this yellow cell that I've marked, where does that appear in row 3? It's got to be here, because these others don't have 6, 7, 8, 9 as possibilities. Right, that may be the way to go. That yellow is going to be in one of those 2 places. This is going to be the same as that from the palindrome, and that must be here, so that can't be a 6 either. I don't know though. What? Oh, look. Yeah, we need to look for weird relationships on the palindrome. This is quite interesting. I've just noticed that this cell sees, because it sees those 2 on that end of the palindrome, it sees those 2, and it also sees that one. So this is a set of 4 different 6, 7, 8, 9s. Now, that doesn't really help with this yellow and green highlighting, because they could turn into these colours. I don't know quite what I'm saying, but let's colour this one red. This can be, I don't know, blue. Purple we haven't used, let's put that there, and grey. And these four have to be different because that's purple, that's grey. Obviously blue, grey and purple see each other, and red sees all of them as well. It sees grey and purple in the box and blue in the row. So they're all different. That must be blue because it's the fourth one in box 9. What does this mean? But, sorry, I'm trying to bear in mind, yellow can still be grey or red. Well, indeed, it has to be grey or red. Yellow is either grey or red. Green can't be grey or red. Green is either blue or purple, but we'll have to work out which is which somehow. Oh, now how do we do this? Oh, look, is this right? This is the same as this cell on the palindrome. Oh, I don't know. I mean, what colour have I got? Orange. Let's just call that orange for now. Now that's quite interesting, weirdly. What numbers don't appear in those 4 cells? And the answer is 6 and 7. So in column 7, 6 and 7 have to be in this group of cells. And they are all seen by orange, either in box 6 by that orange, or in row 7 by that orange, which sees grey, which sees purple and blue there. So that orange cannot be 6 or 7. Now, it can still be red, but it can't, or 5. Orange is either 5 or red. That's the sort of knowledge bomb you get on Cracking the Cryptic occasionally. It would make no sense in any other context, but in this puzzle, orange is either 5 or red. Now, if it was 5, we'd have a 5 here, a 5 here. That looks like it works. Can this be a 5? Now, this total, for that to be a 5, we've got a 9 here and 9, 8, 7 down here. 24 plus, yeah, that's right. If this is going to add up to 14, this has to add up to the maximum 24. So if that's a 5, which is a 5 there, then we've got 9, 8, 7 here. Then red is 6, because that's the other large number. That's if there's a 5 in one of these cells. I don't know, does that doesn't do anything. Oh, that's a thought. For this to be a 5, on a 32 diagonal, the other 3 will all be 9s. The same's true with this. I don't think either of these can be a 5, and I think that's interesting. Right, the reason I don't think they can be a 5 is if these both become 9s, then yellow has to be 8. And that needs 2 more 9s on the diagonal, and suddenly you've got a 9 clashing with a 9 in box 4 and column 1. That's no good. You can't have a 5 on this diagonal. So orange has become 8 or 9. This one is not a 5 as well. The only way to get a 5 on this diagonal now is to put it here. Oh, never mind about that. Purple, blue and grey all see this cell. And that is the 4th of the set down in box 9. So that orange is red. Bingo. Right, we've got rid of orange. Orange has become red. The puzzle is getting gorier. Yes, red there, red there. This is the only place 8 and 9 can be. Yellow is also red. So we are getting very gory. Blood all over the place. Right, now we're on to something. Now we're going to get red in one of those 2 cells. Red can't be grey, so that's red. And red in one of those 2. So that is the fourth 6, 7, 8, 9 down here. Now, can we do more on either the 32 or the 39 diagonal? I'm sure we can. Right, this is 8 or 9. Yes. So this cannot be the maximum 987 to allow that to be a 5. So that is not a 5 anymore. And therefore, this is the other colour that sees red, blue, and purple. That is grey. And the fourth grey remember green. Green, what colours? Green can't be grey, actually, because it sees it here. So the grey in column 9 has to be there. We still don't know whether green is blue or purple. That's the last colour match we have to achieve. These two are blue and purple. I don't know how to use that. Right, come on, we're getting close now. Seems to be all on this diagonal. Right, this either adds up now to 22 or 21, depending on whether that's 8 or 9. 21 or 22 plus 1 is 22 or 23. So these two add up to 16 or 17. So they don't include a 6. They definitely include a 9, and they're both in the same box with red, which has become 8. So, Mr. Red, we know what you are. You are 8. Let's take 8 out of all of these other cells. Can't be in there. Green is not red. There's another of those brilliant statements. Right, none of those can be 8, I reckon. So we're getting close. Now, this is a 6, 7, 9 triple, and that's a 9, 7. Does this add up? 20, I think I just did it this way, so it must do. 16, 22, plus 1 is 23, plus 16 is 29. Yes, that's good. Okay, this can't be, I don't know whether it's blue or purple. I do know it's green, weirdly, because it's got to be the same as that cell, whether it's blue or purple. So I'm going to colour that green. I still have to discover whether green is blue or purple. Oh, this is so weird. Right, let's keep going. Let's keep going. What about this again? And this is... Oh, this is on the palindrome. I haven't been keeping my palindrome up to date. Right, that is in fact green and is 7 or 9. Eight plus. So if this was 6, 14, these would both be 9s. Is that possible? Well, green would have become 9 at this point. And it couldn't be purple, so blue would be 9. And that looks like it works, so it's probably right. There are 9 there. But that is not proof. Have I forgotten? Yes, I have forgotten this 34 diagonal. 8 and 8 there. Brilliant. Green is 9 because these two now have to be 9 to make up the sum. Yes, so that's not 9. Green is 9, so all these greens become 9. Now on this palindrome, 17, so we have 15 in these two cells. So this one can't be 6 anymore. Blue is now 7 or 9, so is grey. And therefore blue is not... Oh no, blue could be green. In fact, grey has become 7. If grey is 7 or 9, is that right? Have I... Yes, since we got a 9 there, grey is 7. That is simple, right? 7 is grey. Blue must now be 9, because up here I'm saying it can't be 6. I just want to check that. 23, because that can't be 9. Yes. Blue blue is 9, and therefore blue is green. Let's turn these blue cells green. There we go. And now we have the colouring of the 4 big numbers. Grey is 7. Purple is the other one. Purple is 6. Red is 8. Oh, yes, hang on. 18, 26. That's a 6, so that's purple. And this is where red is in these 2 cells. That is nothing. And we can fill in the 8s in those. So we've got all the 8s in the grid now. We've got all the 9s. Once we fill in a 9 here, that wasn't where I thought it was going. There's a 7 and a 6 down here somewhere. This puzzle's so intricate. It's like a delicate veil. Now that's a 6 because of the colour. No, well, because I calculated that little killer clue. Now this one, 32 with a 6 and 7 in it. So these two add up to 9. And they can't use 6, 7, 8 or 9, either of them. So they must be a 5-4 pair. And they're different. Does that help? No, not really. Certainly not yet. Oh, this is on the palindrome. We must... No, I haven't done it. I don't know what it is. I know it's not 1, 6, 7, 8 or 9. How about the 48 now? 9, 17, 23, 29. These 4 cells add up to 19. That's almost average values. That's not very useful. Right, we've got a 4, 5, 7 triple here. So that's not a 7, indeed. That's not a 6. One 6 is here in this box, and that is 6, of course. Should have done those earlier. But I don't think I can finish off the other 6s. There's a 6 in one of those cells. 7. Can't finish off the 7s either. Haven't used these eyes as odd numbers yet, but I don't think they're very helpful yet. Dare say we'll get there in due course. Is it Little Killer? Am I forgotten some poor little killer clue that has got information to give? I think it's only the 9 one, so no. I mean, sorry, only the 48 diagonal. Right, so I just need to do a bit more Sudoku probably next. Which is not unreasonable in a Sudoku puzzle, I suppose. This sees 1, 2, 3, and 6, 8, 7, and 9. So that's 4, 5. That's a pair with that. So the other 2 in the column are 6, 7. I might as well give them a bit of purple-grey shading. I don't know which is which yet. If that's a 6, that's a 6. That's all right. Get me very far. 6 is in one of those cells. 9. These are from 2, 3, 4, or 5. Two there. So 2 is confined to these places. Oh, so 2 in this row is only in one of those 2 cells. Ah, and this palindrome cell is quite interesting. 2 in row 6 is confined to one of those 2 cells. And that means that one of these 2 cells is a 2. And that's ruling 2 out of a couple of places in column 4. So actually, 2 can now only be in one of those 2 places in box 5. Can't be there. It also can't be here. So 2 in row 8 is in one of those 2. Is that useful? Sure. Not sure. It could be. Feel like marking it. These are quite limited positions for 2s in some places. I don't know what to do with them. Sorry. Oh, look, there's a 2-4-5 triple. Only place for 3 in this column, apparently, is here. Why can't that be a 3? Because of the diagonal. Okay, yeah. 3 there. So that's a 5. Ah, now we're getting somewhere. Ooh, that's limited this down. 5 there gives us a 4 here. That's on the 22 little killer, so that becomes a 5. Now we're getting somewhere, surely. 5 there at the top. That's a 4. That's looking down here. That's a 5. Come on, keep going. This can't be a 5 on the palindrome, so 5 is here. Is keeping going. Doesn't often do that when I say that. That's 1 or 2. That's 1, 2, or 4. No, this isn't a 2 because we worked out 2's in one of those 2 places because 2's in one of those 2. So that's a 1. That's a 2-4 pair, so that's a 1. Don't know whether 1 is that cell or that cell, but that's not a 4 now, and that's on the palindrome, so that's not a 4. We've got a 2-4 pair, so that becomes a 3. 1 and 3 are resolved. That's on the palindrome. 3 and 1. I could have done that once I got the 3 this side. That's become a 4. This is a 2. That's where 2 does go in the box. That's a 2. This is 3. Yes, we got that. The whole palindrome is done now. That is 1 or 2. That's 1, 2, or 4. So this is a triple. This is a, oh yeah, this is a 3, 6, 7. Triple down there at the moment. Now let's have a look at our diagonal. 12, 25, 34. Right, these 3 add up to 14. I'm giving them orange. They add up to 14. What does this sell? 4, 5, or 7, I reckon. This one can't be 1, 4, 3, 8, 9, or 6. 2, 5, or 7. So if this was a 7, then these 2 add up to 7 as well, which would have to be 2 here and 5 here. But if that's a 7, this can't be a 5, because what do you do here? Impossible. So that's a 5. 7 there. That's not 7. Now these 2 add up to 9. So they're a 4, 5 pair. That's a 5. That's a 4. Come on, here we go. Too many choices. I don't know what to do next. That's a naked single 1. 2, 5 pair. That can't be 2 or 5 or 3. That is in fact 4. That's a 2. That's a 5. Nonsense about the naked singles. There were easy box deductions to do. So this is a 3, 7, 6 triple. Still haven't used the ghost's eyes. Maybe we're not going to have to. Still don't know about that 6, 7 pair, which is weird. Right. That's not a 7. We've got 6, 4, and 3 to finish in column 5. That is 3 or 7. Didn't matter that it was ghost. That's just Sudoku. 5, 6, or 7. So that's now 5 or 7. So I am slightly using the ghost thing. Oh, in fact, that's the only place where 5 can go. So I didn't need the ghost eyes at all. 5 there. That's the last 5 in the grid. Would have written that in ages ago. 1 must be here. Oh, no, we've done all the diagonals, haven't we? We've done every little killer clue. So the rest is just regular Sudoku. Come on, can't be. There's so much intricacy already in this. It can't be hard to finish now. And it? No, 6, 7 pair there. So that's a 4. That's a 2, 4. Here we go. 2, 4, 1, 4, 2. The 1 has fixed the 1, 3 pair finally, which we had ages ago. 2 is here. So we know that that's a 7. That's a 6. That's a 7. That's a 3. This must be 6. Let's finish off the colouring in a moment. 3, 7, 6 there. Right, let's make that just purple and that just grey. And to finish off the 6s, we'll go here, purple. To finish off the 7s, which are grey, we find them in these cells. That gets all the colouring done, and now we can do the numbers. 7 there, 6 there, and a 3 in the middle, and the spectre is complete. That is a very clever puzzle from James. Very suitable for Halloween. I was a bit scared at one point in the middle. I don't know, there may have been other ways of getting through this other than finding a separate 6, 7, 8, 9 and using the crazy colour system, but that's how I did it. Do let me know of different ways of getting through this puzzle. That was very interesting and good fun. So very happy Halloween to you. Have a great November as well. And we'll see you tomorrow streaming at 10. Simon's video an hour and a half before that. My video an hour and a half into it. And Patreon at 4 p.m. with the monthly reward, and probably at some point during the day or the next day with the Zeta Math Solve. Loads going on. See you then. Bye for now.